Guys, my name is Mfundo. I need you guys to help me with number C.
Waste of time. According to this question, we are told that one of the seven ancient wonders of the world was the Great Pyramid of Cheops in Egypt. I hope I'm pronouncing that well. One side of its square base is M. Okay, it's got a square base. Very important for you to keep that in mind. So one of its the side of its square base is actually M units, which is in this case is actually M meters. Number one says, if AB is equal to BC, very important for you to keep that in mind. We are told already off the bat that the line AB is equal to the line BC. So I'm going to mark that on my diagram because I need to make sure that I'm not making mistakes by neglecting the love letter. You need to read the love letter until the end and then put the information on the drawing because you'll be able to see what the story is. Right. And then angle ABC is theta. So there's an angle there at the top which has got a value of theta. All right. And then angle BAD is alpha. We can see there's alpha right there at the bottom. Prove that the height of the pyramid is BD equals, so we're looking for the height of the pyramid, which is the side BD. It is equal to M sine alpha cos half theta divided by sine of theta. All right. So basically this question is easy, guys. You don't have to stress yourself. Like we said when we're doing 3D and 2D questions, you need to do one thing and one thing only. Identify the triangles that are involved in the question. If you can isolate them, do so. And then the first triangle that you're dealing with is a triangle that has got enough information. What is enough? Enough is three things. At least if it's got three things on it, you can be able to do something and then work out whatever you need until you get to the triangle that has got what you want to actually count. Okay, cool. Right, so let's see here what the story is. According to this, we have a triangle. I'm going to isolate these triangles, guys, and try to work out the height BD. Let's see what will happen there. So I've got a triangle here, which I'm going to draw, and then we will actually look at that later. It's got D at the foot, and then there's B at the top, and then there's A right there, right? And then there's another triangle, the second one, which I'm now going to try and draw in a different color. There's the second triangle, which is the one that I want us to look at. It has got B at the top, it has A here, and then it also has C here. We know that this line is equal to this line, right? Immediately, you can clearly see that I'm dealing with an isosceles triangle. So we want to actually work out the length of the BD value that you have looking at there. Right, now what is AB? AB is unknown, right? BC is also unknown. We don't know what those sides are, but we know for a fact that M is the length of the side here at the bottom. And we also know that this angle here is basically theta. That's what we actually know. We are looking for the common side between these two triangles. So if you look here, the common side, if I work out the side AB, it is the side that is a member of the triangle that I'm currently dealing with, which is triangle ABC. It is also a member of triangle ABD. That's basically what we are currently working with. So if I know what AB is, then I can be able to use this information to try and figure out what I'm looking for, right? So let's see what the story is going to be in this case. So if this angle is what I'm dealing with here, I can actually try and figure out what the angle that we are looking at right there is going to simply be. All right, so this is angle C according to this question. And if you look further, we can be able to do a lot of very interesting things in this, which means we can say this angle C will be the same as the other angle on this corner here. It's going to be the same as the other angle on this corner here. And I'm going to try and represent those angles using theta. So according to this, angle A plus angle B plus angle C must give us 180 degrees. And this is because we're dealing with sum of interior angles in a what? In a triangle. Now, what is angle A? I'm going to call angle A and angle C equal because they are both basically the same since this is an isosceles triangle. So I'm going to say angle A plus angle theta, let's call it theta because B is theta, plus another angle A because C is the same as angle A, must give us 180 degrees. If you simplify further, you can clearly see that theta, right, plus 2 times angle A will give you 180 degrees. And if you simplify further on this, you'll be able to see that according to this question, your angle A, which is very interesting, is 2 times angle A is 180 degrees minus theta. And if you divide everybody by 2, you'll get 90 degrees minus half of theta. Very important for us to keep that in mind. But therefore, that means also angle C will also be the same thing, which is 90 degrees minus theta because we are dealing with an isosceles triangle. So now I've got that information and I'm going to just paste it here. This angle is 90 degrees minus half theta. This angle is also 90 degrees minus half of theta. So in this triangle, I'm going to look for this side, which is opposite that angle. Now, which trig ratio will assist me in this case, guys? Very easy. I'm going to use the sine rule. Why? Because I've got the angle and the line opposite that angle. I also have another angle. I'm looking for a side opposite one of those angles. So according to the sine rule, that side there, which is AB, I'm going to write it here. AB divided by the sine of angle C will be equal to the line opposite to theta, which is M, over the sine of theta. Absolutely interesting stuff. So if I make AB the subject, my AB will just simply come out as M sine of the angle. What is my angle? Angle C. We found it to be 90 degrees minus half of theta. Everything divided by what? Everything divided by the sine of theta. Beautiful stuff. Now, according to our reduction formulas, guys, very powerful stuff. You know for a fact that if you are dealing with sine and you have 90, it will change to its co-ratio. So sine of 90 minus will simply change to cos of half of that angle. Everything divided by what? By the sine of theta. Absolutely interesting. So I just found the length of AB. I just found the length of AB. Now, if I reconstruct that triangle we started with, that has got the length we're looking for. It's got 90 here, there's A here, it's got B there, and we know what the length of AB is. There's D here. And then I'm looking for the height of the tower, knowing for a fact that the angle here is alpha. And I know again that this side AB, we just found the length of that side. So I'm going to ask you a very simple question. When you've got a right angle triangle and you're looking for a side, can you apply a SOHCAHTOA? Yes. I'm just going to use sine because it's opposite side divided by the hypotenuse. But the sine of what? Of alpha. Very powerful stuff. Now, if you go back to this, we can clearly see, okay, this is not complicated. Sine of alpha is the opposite side, which is what we are asked to work out, divided by the hypotenuse side, which is AB. And if I apply cross multiplication, AB multiplied by the sine will go on the right, BD will come back here. So BD will be AB multiplied by the sine of alpha. And then at the end, we can therefore say the line we're looking for, which is BD. Let's write it clearly so that you guys can see. It's a very nice question indeed. I like this question because it's actually reopening our minds when it comes to what we're looking for. But what is AB? What is AB? We just found what AB is. According to this question, AB is M cos half theta. So we are dealing here with M cos of half theta multiplied by, right, because we have the numerator, but there's another sine of alpha there on the numerator, sine alpha divided by the denominator there, which in this case is the sine of theta. Very powerful indeed, and I hope it really helps you to see what is going on when you're dealing with 2Ds and 3Ds. Find a triangle, use sine rule, cosine rule, error rule, whatever you might need to use, and then you'll be able to get the correct solution. Thank you very much for sending the questions through, and thank you for staying with us. We're still coming back with a lot of very exciting content. Don't go anywhere. We'll be right back.